Welcome to the beginning of Chapter 3, where we're going to start looking at how do we summarize, analyze, and report on the data that we've collected through our survey or our research project and observations. Specifically, 3.1 deals with the measures of central tendency. When we look at a distribution of data, we should consider three characteristics of the distribution: the shape, the center, and spread. And when we're talking about the distribution of data, what we're really just talking about is how people responded, and then how are the responses grouped. If you're doing kind of a survey, how many said strongly agree versus strongly disagree, and all the categories in between. That is the distribution of data. The center and spread are numerical summaries of the data. The center of data is commonly called the average. This is one of the most common used and well understood concepts in mathematics. Once these three characteristics of the distribution are known, shape, center, and spread, we can analyze the data for interesting features, including unusual data values called outliers. Here we're going to look at the arithmetic mean of a variable from raw data, determine the median of a variable from raw data, explain what it means for a statistic to be resistant, and determine the mode of a variable from raw. A measure of central tendency numerically describes the average or typical data value. The three most widely used measures of central tendency are the mean, the median, and the mode. In the media, why do they use that? Newspapers and blogs and so on, average usually refers to the mean. So, when we talk about an average, a mean is usually the word, one of the three calculations of central tendency. The mean is the same as the average. But be careful, some reporters use average to refer to the median or mode, which is not the average value of a distribution or a set of responses. These three measures of central tendency can give very different results, as we're about to see. Let's look at some definitions. The arithmetic mean of a variable is computed by adding all the values of the variable in the data set and dividing by the number of observations. This is what you know. The arithmetic mean is, if you want to know your test average, add up all your test scores and divide by the number of tests. It's nothing more than that. The population arithmetic mean, and this is the symbol for it, it's the Greek symbol mu. Any of you guys that are Pokemon fans, you might remember mu. Mu is computed using all the individuals in a population. So our denominator up here, like we were talking about the tests, the population will be all the people in or all the counts in our population, because it doesn't necessarily have to be people. It could be, you could be studying bacteria or something. So the total population will be our denominator. The population mean is a parameter. It's a mathematical measure, and we look at that in Chapter 1. The sample arithmetic mean, pronounced X bar, you have a letter X with a bar on top, X bar. This is the sample arithmetic mean, is computed using sample data. So we have a population arithmetic mean if we have all the data on the population, and then of course if we take a research of part of that, or we do a study of part of that, we use a sample. The sample mean is the statistic. So here the denominator will be how many, what is the population of our sample? How many cases or individual samples did we have? While other types of means exist, the arithmetic mean is generally referred to as the mean, just the mean. You don't usually have to say arithmetic mean. Calculations. Population mean, mu. Add all the variable observations and divide by total population. So if we have all the data from each of the population parts, we just simply add all those responses or observations, that's the numerator, and divide by whatever the population is, N, capital N here, or uppercase N. For sample mean, or X bar, we add all the sample variable observations. These are documented the same way. We would just add up whatever the responses are and then divide by the sample size. So I'm saying add up the responses, but it might be, again, if we were thinking about like an opinion survey that goes from strongly agree to strongly disagree, for the sample, you would say, for example, we would calculate the mean of each category. So the number of people that responded strongly agree over the total sample. The number of people that responded agree over the total number in the sample, etc. And here we would do the same thing, assuming we had the data on the entire population. So let's look at an example, computing a population and sample mean. The data in Table 1 represents the first exam score of 10 students enrolled in introductory statistics. Treat the 10 students as a population. So our total population here is 10, right? This is our entire population. Compute the population mean. Well, remember what we have to do here is add up all of the individual numbers, the individual scores, and then divide by the population, which is 10. Well, if we add up all these numbers from these 10 students, we get 790. Divide by 10 gives us a 79. Using your TI-84, find a random sample of size 4. We did this in Chapter 1, so see if you can set that up to find a sample, to find a random sample of 4 students. Remember that you have to set your calculator up using just kind of picking any positive integer value, and then you can use the random integer values, and this is no response, or no replacement, excuse me, because you can't pull a student out and then put them back in the calculation. So when you have replacement here, then you could get 5526 or something, because you could use the same person again, and we don't want that in most statistical studies. I can't think of an example right offhand. So notice that we have used the TI-84, and in this example we got 5, 10, 2, and 6. Okay, so our sample is going to be made up of student 5, student 10, student 2, and student 6, which gives us Jennifer, Juan, Ryan, and Dave. Okay, 5, 10, 2, 6. Okay, compute the sample mean from Part B. So now we're going to do this a similar thing, but we're just going to take the scores for the 4 people from Part B. So Jennifer, Juan, Ryan, and Dave, add their scores together, and then divide by the total number in the sample, which is 4. So when we do that, adding those 4 scores together, we get 295 divided by 4, which is 73.8. So the sample mean is 73.8. The population mean is 79. Let's look at some definitions. The arithmetic mean of a variable is computed by adding all the values of the variable in the data set and dividing by the number of observations. This is what you know. The arithmetic mean is, if you want to know your test average, add up all your test scores and divide by the number of tests. It's nothing more than that. The population arithmetic mean, and this is the symbol for it, it's the Greek symbol mu. Any of you guys that are Pokemon fans, you might remember mu. Mu is computed using all the individuals in a population. So our denominator up here, like we were talking about the tests, the population will be all the people in our, or all the counts in our population, because it doesn't necessarily have to be people. It could be, you could be studying bacteria or something. So the total population will be our denominator. The population mean is a parameter. It's a mathematical measure, and we looked at that in chapter 1. The sample arithmetic mean, pronounced X bar, you have a letter X with a bar on top, X bar. This is the sample arithmetic mean, is computed using sample data. So we have a population arithmetic mean if we have all the data on the population, and then of course if we take a research of part of that, or we do a study of part of that, we use a sample. The sample mean is the statistic. So here the denominator will be how many, what is the population of our sample? How many cases or individual samples did we have? While other types of means exist, the arithmetic mean is generally referred to as the mean, just the mean. You don't usually have to say arithmetic mean. Here we're looking at scores on a first exam across the board. It helps to think of the mean of data set as the center of gravity, or the center of the charge, or etc. In other words, the mean is the value such that a histogram of the data is perfectly balanced with equal weight on each side of the mean. As you can see in this diagram, we would have an equal weighted side from 60 to 79, as we would from 79 to 95. The figure shows a histogram of the data in table 1 that we just looked at, with the mean labeled, and the histogram balances at mu, not u, mu equals 79, which is the population mean. Now let's look at another concept of central tendency, and that's the median. The median, which we denote by the capital or uppercase letter M of a variable, is the value that lies in the middle of all the data when all of the data is arranged in ascending order from lowest to highest. We use M to represent median. Step 1 is to arrange the data in ascending order. So take all the responses and put them in ascending order. Step 2 is to count how many observations you have, specifically noting if they are odd or even. And then depending upon if they're odd or even, then you can determine the observation that's in the middle of the data. If the number of observations is odd, then it's really straightforward, because let's say, for example, you have 9 responses. Well, then the 5th response, which is exactly in the middle, 4 before it and 4 after, would be the median of your responses, okay? If the number of observations is even, you now have to do a calculation. So, for example, if you had 12 responses, you can't pick number 6, which seems like that's half of 12, right? That seems like it should work. But if you pick 6 as the median, notice you only have 5 responses before it, but then you have 6 responses after it. So it's not exactly in the middle. So what you do here is you take the average of the 2 middle observations, the average of them, or the mean of them. So just add those 2 together and divide by 2, and you'll get your response. So in that case, where we had 12 responses, we would take the 6th and the 7th response, add them together, and divide by 2. Okay? Remember, of course, we first have to set up this data in ascending order from lowest value to highest value. So let's do a couple examples. Determine the median of a data set with an odd number of observations. The data in Table 2 represents the length in seconds of a random sample of songs released in the 1970s. Find the median length of the songs. Well, remember, the first thing we have to do is to arrange them in ascending order from smallest to largest. So we start with 179, and then 201, 206, 208, etc. Okay? Then we count the numbers. Is it odd or even? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 of them, so it's an odd calculation. An odd number of responses, and this is the easiest kind of median to find because it's the number right in the middle, which in this case is 217. Okay? The median is the observation exactly in the middle of the data set when there's an odd number of reported observations. Now let's do another one. Let's determine the median of a data set with an even number. This is the same data we just saw that we used in example 1. I don't even remember what we did back there. How funny is that? Oh, we're doing the means. So again, the first thing we're going to do is put all of the data in ascending order. Okay, so it looks like 62 is the lowest, then 68, 71, etc. Okay. Then we count to see if we have even or odd number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, they're numbered there. I could have seen that. So we have an even number. Okay. So what we now need to do is to find the two middle members. So there'd be 4, and then 77 and 82 are the middle. So you have 5 and 6, member 5 and 6 in the ascending order. And now we find the average between 77 and 82. Well, remember, we just add 77 and 82, divide it by 2, and we get a median of 79.5. And so if we did a histogram again, this would be the value directly in the middle of the histogram. Okay, so these are not so difficult to calculate. And again, even this number, you can notice that half of the students scored less than 79.5, 1, 2, 3, 4, 5, and half of the students scored above 79.5, 1, 2, 3, 4, 5. And that's the idea of the median. It's the middle value of all of the observations.
Hi, this is Don. This is a quickie to show you how quickly you can use StatCrunch if you're inside my stat lab to solve a problem which is asking you to calculate the mean, median, and mode of some data. If you're in my stat lab, you can click on this little icon, open in StatCrunch, and we have our data in StatCrunch in this column labeled var1 for variable 1. If we go to stat, summary statistics, and our data is in columns, we pick var1 by double clicking on it, and I think we'll have the mean, there it is, the median, and the variance, and then standard deviation. So let's just click on compute, and there we have our data, the mean, the median. But what I didn't select was mode, and I think that was the third requirement. So let's go back into options, edit, and let's look down here. I want to click on mean this time, rotate down, median, there's the mode. So I've selected those three, click on solve, and it tells me that there was no unique number for the mode. So, but anyway, we have our answers. The mode does not exist, which
Next, we're going to look at the last objective, what it means for a statistic to be resistant. A numerical summary of data is said to be resistant if extreme values, very large or small relative to the data, do not affect its value substantially. Again, the summary of data is resistant if extreme values, very large or small relative to the data, do not affect its value substantially. So let's look at comparing the mean and median. Yolanda wants to know how much time she typically spends on her cell phone. She goes to her phone's website and records the call length for a random call sample of 12 calls shown in Table 3. Find the mean and median length of a cell phone call. You can go ahead and hit pause and figure that out, and then hit play again when you're ready to move forward. Here's a table generated by technology. This wasn't StatCrunch, this was actually something called Minitab, another application that you can get. And we can see that the mean is 7.25 and the median is 3.5. Which of the measures of central tendency do you think better describes the typical phone call? Since only one phone call is longer than the mean, right? The mean was 7.25, and we only have one call that's larger than that. The mean is not really representative of the typical call length. So the median is the better measure of central tendency for this data set. So let's look at some guidelines to talk about the relationship between the mean, median, and the distribution shape. Notice that we have a table here that matches up with the diagram below. If the data is skewed left, this means the mean is substantially smaller than the median, okay? If it's symmetric, here we can see the mean is substantially smaller than the median. If it's symmetric, the mean is roughly equal to the mean. And if it's skewed right, the mean is substantially larger than the median. In the last example, what did we have? Did we have data that was skewed left, symmetric, or skewed right? Well, remember the mean was much larger than the median. So we had data that was skewed right. Now let's look at our next example describing the shape of the distribution. The data in Table 5, down to the bottom right, represents the birth weight in pounds of 50 randomly sampled babies. Use your TI-84 calculator to do this problem. A, find the mean and median birth weight. So hit pause now, use your TI-84 calculator, and find the mean and the median from the data in Table 5. B, describe the shape of the distribution, and C, which measure of central tendency better describes the typical birth weight. So if you haven't done so already, hit pause and go and use your TI-84 and calculate the mean and the median. Using the TI-84, these are the screens that we would see, and we can see that on the left that our sample mean, or X bar, equals 7.49. And on the right screen, we can see that the median is 7.35, or uppercase M. Since the median and the mean, the sample mean, are relatively close in value, this means we have a symmetrical distribution, or what you might call a bell curve. And thus we will use the mean to represent the central tendency for this data. Our next objective is to determine the mode of a variable from the raw data. This is really straightforward as well. The mode of a variable is simply the most frequent observation of the variable that occurs in the data set. This is the most common answer. So if you're doing like a preference survey, the answer that most people pick is the mode. It has to be an identical answer, and that is what's considered the mode. And it may not be anywhere near the mean or the median. It's just the most common, the most frequent choice or most frequent observation in a study. A set of data can have no mode, one mode, or more than one mode. It has no mode if there's no repeating answers, if there's no answer that's used more than once. It has one mode if one answer has the majority or has the most, if one answer has more persons picking it or more observations than any other. It can have more than one mode if multiple answers have the same high number of selection. So like if two answers both were picked like 15 times each, and that's the highest number, then they are both the mode. So there can be more than one mode as well. So let's look at a couple of examples to find the mode of quantitative data. Example 1. The following data represents the number of O-ring failures on all space shuttle flights prior to the fatal flight of the Space Shuttle Columbia that occurred on January 28, 1986. And so you can see the data here. 0, 0, 0, 0, 0, etc. 1, 1, 1, 1, 2, 3. Find the mode number of O-ring failures. So go ahead and do that. And I'm going to read example 2, and then we'll talk about the answers. Find the mode of the exam score data listed in table 1, which we've been using throughout this section, which is repeated here, 82, 77, 90, etc. So when you're ready, hit pause, and when you're ready, when you think you've identified the mode, for example 1 and example 2, then hit play again. So in example 1, the mode is 0 because notice this is the response that happens most often. In fact, it happens 17 times. And that's all the mode is which response happens the most number of times. In example 2, however, we have no repeating responses. None of the answers repeat. So in example 2, there is no mode because there is no answer occurs more frequently than any other. Now let's look at the mode of qualitative data. A data set can have two modes, and in this case we say that the data are bimodal. If a data set has 3 or more data values that occur with the highest frequency, the data set is then called multimodal. In general, the mode is usually not reported for multimodal data because it is not representative of a typical value. Here at the bottom you can see distributions. Figure A on the left has one mode, and figure B is bimodal because it has two modes. So let's look at example 1, the mode of qualitative data. The data in table 6 represents the location of injuries that required rehabilitation by a physical therapist. Determine the mode of location of injury. So again, what we want to do here is look at all the different types of injury. I see hip, knee, shoulder, back, wrist, elbow, groin, hand, neck, etc. I see quite a few knees, etc. And really what we should do is list them maybe in alphabetical order and then just count each one to find the mode. But see if you can determine the mode of location of injury. When you have that, hit pause. When you have that, hit play again. So it's pretty clear that back happens a lot more than anything else. I think knee is the second, but it's not even that close. The back occurs with 12 instances, and that's actually not even surprising to many of us that have had sports industries or just movement injuries. I keep saying industries. Excuse me. So this mode is pretty straightforward, one of the easier concepts to kind of calculate and see what happens. So looking back across this section, the measures of central tendency are mean. And remember, this is kind of the center of gravity or average. We had two different kinds of mean. One was the population mean. If we had data on the entire population, this was represented by mu, and it was all of the observations divided by the total population. And then if we had a sample study, a smaller sample of the population, then we calculated a sample mean. Again, we're summing up in the numerator all of the observations and then dividing, in this case, by the total number of samples that we had or took or observed. Okay. When data is quantitative and the frequency distribution is roughly symmetric is when you want to use the mean, and then your statistics becomes more resistant. For median, remember this was the value in the middle that divides the actual data, the bottom 50% of the data from the top 50% of the data. It's not the numerical average, it's just the middle responses, if you will, or the middle response, I should say. So remember the way we did this, we first arranged all the data in ascending order from smallest to largest. We determined how many observations there were. If they were odd, we could pick the exact middle number, and that is the median. And if it was an even number of sample or observations, then we had to take the two middle numbers, because there is no middle number, and find the average of that, and then that would become the median. Okay? We use this when the data is quantitative and the frequency distribution is skewed left or it's skewed right, when it's skewed left or skewed right. And finally, we look at the mode. The mode is what we just did, and this is just looking at all the answers and just seeing if any response has, which response has the most, is used most frequently, okay? It's the most frequent observation or response. When the most frequent observation is the desired measure of central tendency, or the data is qualitative. So we use this when we have qualitative data, or if it is actually kind of relative, that more people are picking that, or more observations are that one. Okay?